Hello friends, let us solve another example on rotational mechanics. We are looking at Hcverma example number 82. It is there on page number 200. Page number 200. Let us see the statement. There is a thin spherical shell lying on a rough horizontal surface is hit by a cue horizontally such that the line of action is through the center of the mass or center of the shell, right? And because of this, the shell starts moving with a speed v. We are supposed to find the linear speed of the shell when it starts pure rolling. So they have given that this is the shell. It is lying on a rough horizontal surface. Hello? हाँ केला हाँ चालेल ठीक बरं. So as a result, it moves with a speed v. Let me take this as v naught. It is easier to do it like this. So the initial velocity is v naught, but initial angular velocity is given to be 0. It is given to be 0. Now for pure rolling, again we have a situation v is equal to r omega. So now v naught must decrease and omega must increase, so that at one particular stage they will match, and so the force of friction now will be in the opposite direction. This will help to increase the angular speed. At the same time, this will oppose the linear speed, so the acceleration, linear acceleration, will be negative. Again, if you use F is equal to ma, our acceleration will be F upon m. At the same time, if I use F into r is equal to I alpha, since it is a shell, it's a hollow sphere, and in this case alpha will be positive, so alpha will be 3f upon 2mr, right? This will be positive, whereas this will be negative. So v will be v naught minus 80, and omega will be omega naught. Omega naught is 0, so let me directly write plus alpha t. Again we will follow the same funda. For ft upon m, we will write v naught minus v. For ft upon m, we will write v naught minus v, and we should quickly be able to get the answer. So we have omega equal to three r upon 2, and ft upon m is v naught minus v, and of course for pure rolling you can write omega as v upon r. think this r is in the denominator, excuse me. So V upon R and that gives you the velocity as 3/4 times V naught. This 2 will transfer here. Sorry, it's 5. 2 plus 3 is 5. You can do the math part. Sometimes I tend to make mistakes. This 2 will transfer here, I just forgot that. So 2v equal to 3v naught minus 3, and the answer is 3v naught upon 5. Let us do the last example in this series, which is similar, using similar concepts. So let us solve example number 83 from Hcverma. A hollow sphere lies on a smooth horizontal surface, so there is no friction. So this is a different sum here. You have not come across a situation when there is a smooth surface. So the hollow sphere, it lies on a smooth horizontal surface. It is hit by Q in such a way, it is pulled by a horizontal force acting tangentially from the highest point. Find the distance traveled by the sphere during the time it makes one full rotation. They are asking how much is the horizontal distance traveled when the sphere makes one full rotation, means when the angular displacement is 2 pi. Okay. So now in this case, we do not have friction, so the only force acting is the force F. So let us have two equations here. The first equation is F is equal to ma, and the second equation is the torque R. The torque R will be given by F into R is equal to I alpha. What is I? It is a hollow sphere. So that gives you alpha as 3F upon 2m. Now please note that as the sphere is moving in the forward direction, omega will be in this, and the torque is producing anti-clockwise, and that will produce a negative acceleration. So alpha will be negative, whereas A will be positive. Now let us use the simple equations. V is equal to u plus at. Initial velocity is 0, so V will be A will be F upon m, and omega equal to omega naught minus alpha t, but omega naught is 0, so minus sorry, I think it is producing a clockwise torque, it will be plus, my mistake, it's producing a clockwise torque, absolutely sorry, it is producing a clockwise torque and sphere is also moving clockwise, so it will be plus, my mistake. So these are the two equations, but instead of using these two equations, since we are interested in finding a relationship between s and theta, you can use the Newton's third equation of motion, that is v square equal to u square plus 2as. So you can use that relationship also. At the same time, you can eliminate time from this. You can eliminate time from this and you can get the relationship between v and omega. So that also can be done. But let us try. The third equation of motion. That gives me v square equal to 2as and omega square as 2 alpha theta. So that gives me v square upon omega square equal to a into s upon alpha into theta. V is 80, omega is alpha t. That is another approach. There is one more approach which you can use, and that will be, I think, the simplest. That is to use the Newton's second equation of motion. S is equal to half at square. S is ut plus half at square, and omega equal to omega naught plus half alpha t square. So not omega, sorry, theta is the angular displacement. So s upon theta will be simply a upon alpha. So s will be theta into a upon alpha. Let us substitute the values. Theta is given to be 2 pi as it completes one rotation. A is f upon m upon alpha, so this will go up. 3f. Let us cancel m with m, f with f, and the distance travel will be given by four pi r upon 3. Let us look at Example number 84. Same Hcverma, page number 200, rotational mechanics. A solid sphere of mass 0.5 kilogram is kept on horizontal surface having a coefficient of friction 2/7. Asking the force applied at the highest point. So that the sphere does not slip, means it starts rolling without slipping. Okay. Now here it may be difficult to find the direction of frictional force, but please note we want to increase the value of V. At the same time we want to increase the value of omega. So in order to increase the value of V, let us assume the force of friction to the right. Please note, suppose you take force of friction to the left, you will get answers in negative form. If we get negative answers, it means that our direction is wrong. So in 99% of the cases, when there is a force applied at the topmost point, the force of friction is also to the right. Please note this. This will help us. We are supposed to find the value of F for pure rolling. So let us apply now the same fundas. The net force in the forward direction is F plus F, and that gives you the acceleration. At the same time, the torque, you can see, since the sphere is rotating clockwise, F into R produces a clockwise, small f into R produces anti-clockwise torque. So equal to I alpha, since it is a solid sphere. Now, since the equation V equal to R omega holds for pure rolling, if you take the derivative, dV by dt will be A and d omega by dt will be alpha. So you can apply A equal to R alpha, or you can put straight away alpha equal to A upon R. Please note, this is only for pure rolling. So you will get another equation. So please simplify this. R, this R, this R and this R will cancel, and you will get F minus small f as 2 by 5 m. So this is one equation. And this is second equation. Okay. Now let us subtract these two and find a value of the force of friction, small f. We are interested in getting the answer in terms of mass. Acceleration should be eliminated. So let me rewrite these two equations separately. F plus f as ma and f minus f as 2 by 5 m, and then we will proceed. Now what is F? F is mu into normal reaction, or F is mu into, they have given mu as 2 by 7, so F is 2 by 7 times mg. So keep this in mind, that. 'That. F is 2 by 7 times. So keep this in mind, that F is 2 by 7 times. So keep this in mind, that F is 2 by 7 times. So keep this in mind, that F is 2 by 7 times. So keep this in mind, that F is 2 by 7 times. So keep this in mind, that F is 2 by 7 times. So keep this in mind, that F is 2 by 7 times. So keep this in mind, that F is 2 by 7 times. So keep this in mind, that F is 2 by 7 times. So keep this in mind, that F is 2 by 7 times. So keep this in mind, that F is 2 by 7 times. So keep this in mind, that F is 2 by 7 times. So keep this in mind, that F is 2 by 7 times. So keep this in mind, that F is 2 by 7 times. So keep this in mind, that F is 2 by 7 times. So keep this in mind, that F is 2 by 7 times. So keep this in mind, that F is 2 by 7 times. So keep this in mind, that F is 2 by 7 times. So keep this in mind, let us eliminate small a because we don't want it in the final answer. Small a we do not want in the final answer. So let us simply eliminate this. I am multiplying this equation by 2 by 5. This 2 by 5 MA I can write as F minus F. So 2 by 5 times capital F plus 2 by 5 times small f is equal to rearrange the terms and we will get F minus and bring this on the other side, this on this side. So what do I get here? 3 by 5 times capital F I will cancel. And I will get capital F as 7 by 3 times and small f is 2 by 7 mg. Mg by 3. Now they are given the mass as 0.5. So 2 mass is 0.5 into G is 10 upon 3. That gives your answer as 10 by 3 or 3.33 Newton. They have given the value of mass as 0.5. It is there in the problem. You just substitute it and I get the answer as 3.3 Newton.